Hi, I'm Mrs.D Math. If you've been here before, we welcome you back. If not, thanks for joining us. We're going to be covering similar figures in 7th grade math. Let's go ahead and get started. So similar figures are going to be two figures that are the exact same shape, but the size can be different. So here we have triangle ABC, and it is similar to triangle DEF. When I look at these similar figures, I can see that there are corresponding angles and corresponding sides. So let's start with the angles. So angle A in this triangle on the left corresponds to angle D. That means that angle B corresponds to angle E, and angle C corresponds to angle F. We can do the same thing with the side lengths. So in this case, I have AB, and I can see that I've already made indications to which ones match up. So the part with the side lengths is it has to go in the same order. So since A and then B comes first, the corresponding side length is DE. And then I have BC. I can see it goes from left to right. And so on the larger triangle, that would be the same as EF. So now for the last one, I have AC, which means I'm going to start back at the top. So on the other larger triangle, that means that corresponds to DF. If I look in the original part of the problem, it does tell me that ABC is similar to DEF. So I can see here, because of the order they're in, that A corresponds to D, and B corresponds to E, and C corresponds to F. It's also going to be in the same order. So AB is in order, DE is in order. So there are other ways to see which ones are going to correspond, even if you don't have a picture. If they tell you that they're similar, then you know that they're in the same order. So now we want to know if the angles are congruent and if the side lengths are proportional. So here is my small rectangle, and here's my large rectangle. So I'm going to figure out first for the angles. And in this case, I can see that they are all right angles since I have two rectangles. So because of that, I can say that yes, the angles are congruent. And that's because they are all 90 degrees. Now I need to find out if the side lengths are proportional. In order to check something to see if it is proportional, I need to make two equal ratios, and those ratios are going to be made up of the corresponding side lengths. There's several ways I can do this, but I'm going to go ahead and put 7 over 2, and that means on the other side, the larger side has to correspond with 7, which means 21 goes on top and 6 goes on the bottom. Now I need to tell if these are actually proportional. There's a couple of ways to do this. The way that always works is to cross multiply. So if I multiply 2 times 21, I should get the same answer as 7 times 6. The other way I can do this is to see if they are increasing at the same rate. So I can see that 2 goes into 6 times 3, and 7 goes into 21 also times 3. Since they are both multiplying by the same number, that means they're increasing at the same rate, then yes, these are also proportional. In this third example, we want to see if trapezoid MNOP is similar to trapezoid RSTU. This one's a little different because we do have 3 different side lengths. We've got our 2 bases, which are different lengths, and our sides, or our angles in this case. So I have to make sure that they all correspond. I'm going to go ahead and start up here with the letters because I can tell that the larger trapezoid is in a different orientation than the first trapezoid. So let's look at the letters just to double check which ones actually correspond first. So MN should correspond to RS because those are the first 2 letters of the 2 shapes. And I can see those are both angled sides. So then I can also tell that my smaller base is the 2 and the 6. So I'm going to make 3 proportions here. I've got 2 over 6 equals, and the other 2 bases are 4 over 12 equals 3 over 3. So these should all increase at the same rate. First, I'm going to check the rate of the first part of my proportion. 2 goes into 4 times 2. 6 goes into 12 times 2, which means I can also check it going up and down. So 2 goes into 6 times 3. 4 goes into 12 times 3. So that means that 3 has to go into 3 times 3, which is not true. So that means that this one is not similar. Now we want to find out if these parallelograms are proportional. It looks like they're in the same orientation. I'm going to go ahead and set it up using the side lengths that correspond. So I can see that 5 corresponds to 10, and then that means 3 corresponds to 6. Since 5 and 3 do not go into each other evenly, I'm going to go ahead and check it going up and down. So I can see that 5 times 2 is 10, and 3 times 2 is 6. The other thing I could do is cross multiply. I know 10 times 3 is 30, and 5 times 6 is 30. So both of those ways prove that parallelogram ABCD is similar to parallelogram PQRS. Thanks for joining me today on Similar Figures in 7th grade math. I'm Mrs. D Math. Have a great day. Bye.